For your Cornell notes, if you notice at the top of the page, there's a rectangle way at the top. I want you to write the title for the notes. You're going to write additive inverse property. Additive inverse property. Additive inverse property. Additive inverse property. That's going to be the title for your notes. And today we're going to cover a couple standards. The first one, I want to make sure I cover this property, the additive inverse property. Okay, and that one is found in our number system for our Common Core. And this is to get us ready for what's coming. So this is more like a 7th grade standard going into getting ready for algebra. But the other one that we're going to look at is the Math Practice Standard number 5. What does that say? Using appropriate tools strategically to solve problems. And what tools are we using today? What did I leave in front of you? Algebra Tiles. I put them in little baggies. That's what we're going to use today. Don't open them yet, but those are what we're going to use today to solve a couple of things and get clarification on concepts. Okay? So with that said, here we go. Just to recap on yesterday, I showed you a video to introduce the additive inverse property. Remember that? And here it goes. So it said something like this. If I dig a hole 7 feet deep, how much dirt do I need to cover the hole? Very similar to that. Now, I know some of you already know, but here's just to refresh in your memory. So here's ground zero. Remember that? And here's me, muscles. Look at that. And I'm digging a hole. There it is. How many feet? 7. Okay, so if I dig 7 feet here, how much dirt will be over here? 7. Okay? So now, why do we call this a negative? So that you remember. Since there is no dirt, what kind of word is no? A negative. That's why this becomes a -7. Does that make sense? So if there's dirt over here, that means that yes, dirt. What kind of word is yes? It's a positive. That's why this is a +7. Therefore, these are known as opposite numbers. -7 and +7, bless you, are opposite numbers, and when you combine them, they become 0. In a nutshell, that's what we call the additive inverse property. And I'll give you the formal word and all that in a little bit, okay? So, with that said, to get started with our lesson and to get you set up with your Cornell notes, we start off always with an objective. It's always on the board. Does everybody see it? But also, I also have it on the screen. Look at it on the screen, and it says, I can define and represent integers using integer tiles and 0 pairs. Let's read it together. 1, 2, 3. I can define and represent integers using integer tiles and 0 pairs. So copy that at the bottom left of your Cornell notes where it says objective. At the bottom left. I'll give you about 20 seconds. If you have your colored pens already, use your colored pens. So now, who notices once again that I have different colors for the objective? Everyone, hopefully, right? And there's 2 basic colors that I'm going to be using throughout, red and green. The black is to explain the objective, but what is the main theme for the day? It would always be in green. So what do you see in green? Integers and 0 pairs. But now we already know what 0 pairs are because I already showed you since yesterday the video, the intro. Today we did another intro, but which is the only one I haven't given you a definition for?
0 pairs.
We already got 0 pairs.
No, integers.
Integers. Therefore, we're going to define integers and we're going to represent integers. So we need to find out what integers are. Who notices on your Cornell notes in the center there's a box that looks like this. That box is called a Freyer model. But if you want to call it the box, that's fine. Well, guess what? In the center, we always need to write the main idea for the lesson, or the main concept. That's what we call the main concept. So what is the main concept for today? Integers. Integers. So you're going to write that in the center. So you write integer there. Okay? And on the top left, I'm going to give you a definition. What is the definition of integers? Here it goes. Integers are whole numbers including their opposites. 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 Tell your neighbor what integers are. So, now that we have a definition, there's a couple of terms in that definition that I want to make sure that you understand what they are. The first one is whole numbers. So now, whole numbers, this is what they are. They are counting numbers, but including 0. Let's see. Let's think back. When did we start counting? Let's say when we were in kinder. I'm going to take you back to kinder. You got out of class for recess and you're about to start running. What did the lady on the patio say? No running. And then you started walking fast because you wanted to get to the swings, right? And then you got to the swings and then, I'll race you. All right? So then you start. Ready? -1. No. We don't count in negatives, do we? We counted in positive. We started 1, 2, 3, and go, right? So guess what? Those are counting numbers. But what did I say whole numbers were? Counting numbers including what? 0. So check this out. I want you to draw a number line here where it says example right underneath the word example. And I'm going to first draw whole numbers. So once again, whole numbers, we said they were counting numbers including 0. So I'm going to draw 0. Here's 0. And what are my counting numbers? 1, 2, 3, ... to positive infinity. Positive infinity is that lazy 8 right there. So far so good? So let's see if we got this so far. According to the definition, integers are whole numbers including the opposites. Do we know what whole numbers are? Yes. Counting numbers including 0. Okay, so we know what whole numbers are. But it says include their opposites. So what would be the opposite here? -1, -2, -3, ... to negative infinity. And now we have integers here. Okay? These are all integers represented on this number line. According to the definition, integers are whole numbers, yes, counting numbers plus 0, and their opposites, yes, there they are. So far so good?
Yes.
So let me give you a number. Is this an integer? 12.
No. Yes. No. Yes, it is.
Can 12 be found within these numbers inside?
Yes.
Yes, that's an integer. Copy that. How about 155?
Yes.
Yes, because it goes all the way to infinity, so yes, 155. How about, let's see, -28?
Yes. Yes.
Yes, because look, it goes that way, so can we find -28 over here? Yes. Let's see, how about -267? Yes, that's also an integer. So far so good? Alright, so now, check this out. I'm going to show you over here on this side non-examples. What is not integers. Check this out. Pens down, eyes up here, pencils down. Check this out. Don't say anything, keep it to yourself. Look at them. There's an obvious reason why these are not integers. Look at them. Okay, write them down, and as you're writing down these non-examples, think about what you're going to share with your neighbor as to why these are not integers. Copy those, please. You got about 30 seconds. Think about these questions. Why are these examples of integers, and why are these not? Talk it over with your neighbors, please. Why are these examples? Why are these not? Okay, now that you talked it over with your neighbors, you already know what the obvious reason is, and everybody says what? Because these are what?
They're not whole numbers.
They have decimals and fractions. Okay, so think about this. situation. Let's say your BFF didn't come in today, and they take the same course, similar to this one, and you get home, and then they kick you, or they Facebook you, whatever it is, and they say, so what you doing, Mr. Q's? And you say, oh, we covered integers today. Oh, really? So, what is that? Yeah, think about it. What are integers? What would be the simple way, or two words, or two simple terms that you would say that would cover integers? Think about it. Okay, over here, what would you say? Whole numbers, okay, so then write that up here. That's one thing. What would be another thing? Yes?
Whole numbers and their opposites?
Opposites will be the other one. But underneath whole numbers, just to clarify, just write no fractions or decimals to make sure that they understand. And the other word would be opposites. That's what makes integers integers. Whole numbers and their opposites. What are integers? Whole numbers and their opposites. What are integers? Whole numbers and their opposites. Very simple?
Yes, Mr. Q.
Good. All right. So far we covered the concept, and now I'm going to get into, to make sure we introduce the two properties for today. We're not only going to cover the additive inverse property, we're going to cover one more. Okay, here it goes. My two properties. First one, the additive inverse property. Additive inverse property. We introduced that yesterday, but what does it say formally in words? Let's see, it says, a number and its opposite add up to give 0. Does that make sense? Did I show that in the video yesterday? Yes. Did I show that today in the PowerPoint? Yes. So let's see. What does that say? A plus negative A equal to 0. So they're showing you with algebra, and let me show you numerically. 7 plus negative 7 equals 0. Negative 15 and 15 is 0. And negative 2500 and 2500, that's also 0. This property is called what? The additive inverse property. But from this point forward, we can call it simply 0 pairs. Does that make sense? Why? Because it's a pair of numbers and they make 0. But what property is it? Additive inverse property. Are we there so far? That's one property. The second property, you don't need to copy this. Here we go. The second property that we're going to cover today is the identity property of addition. 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 Now, why identity? Let me show you why. When somebody says identity, it's because it shows me that they're trying to identify something. So let me show you the words. It says, the sum of 0 and any number, at the end you get the number itself. So let's see. They start off here with A plus 0. What is the answer? A. A plus 0, the answer is A. Let me show you with numbers. 7 plus 0, we're left with 7. Now check this out. Let me show you this one. Negative 10 plus 0, the answer is negative 10. This is called the identity property of addition. 1,000 plus 0 equals 1,000. Because check this out. We start with a number, and our answer is identical than what we started with. You see what I did right there? We get, that's called identity property of addition because we start with a number and our answer is identical. Everybody see that? Boom. So far so good? So two properties today, identity property of addition and the other one is the additive inverse property. So far so good? Alright, so next, I need you to clear your desk. The only thing you should have is Cornell note and the baggie of tiles.
No pencils, no pencils.
And you need your writing utensils. Do that right now, please.
It's as big as my head.
Okay. So, the only thing you have in front of you is your Cornell note and your tiles, yes? At this time, I want you to flip your paper over, your Cornell note, and we're going to use the back side. Check this out. So, I'm going to ask you to copy. Hold on, give me a second. Here we go. I'm going to ask you to copy this problem, but before you do, let me show you what your paper should look like in the back. Your paper should look something like this. It's blank just with lines, yes? So I want you to go all the way to the far left, top left corner, and you're going to write example 1.
What if I do my warm-up lesson?
No, your warm-up is on a separate page where all the warm-ups are going. Okay, here we go. Example 1. So then you're going to write show a 0 pair, and then just finish the information. And underneath that, you're going to write -7 plus 7. Does that make sense? Yeah, right?
Yes.
Okay. So copy that problem. Example number 1 on the top left corner. 20 seconds. All right. So this is what we're going to do. It says, look at the instructions. Show a 0 pair using Algebra Tile. So at this time, I want you to get the tiles out of the bags, please. Separate the negatives with the negatives, the positive with the positives, and once you separate them, put them all to the top part of your desk. Move them all the way to the top, so that you leave the space right in front of you as your working space. Okay? So make sure you, if you're a righty, move your Cornell notes all the way to the right side of your desk. If you're a lefty, move it all the way to the left, but leave that center part of the desk so that you can do your work with the tiles.
Oh, bam, how come we didn't use these in summer school?
Because we're going to use them over here. Bam! Ready?
So
here we go. First thing is first. They want us to represent these two using tiles. So what would be the first thing that you're going to grab to represent -7? How many of them? -7. So check this out. So you're going to lay them out like this. I'm going to switch the camera and I'm going to pause this really quick. So what we're doing next, we said we're going to draw the picture under the numbers. Here we go. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. And you drew that on your paper. I know it's not going to look as nice as mine, but try. Okay? Once you have that, check this out. This is what I'm going to do. Do the same as I'm doing. Circle this, and I do this. I cross them out. Think for yourself. Keep the answer for yourself. Why am I crossing these out? Tell your neighbor. Okay, so you just found out, for those of you that were too focused on the tiles, but now you're thinking, you're like, oh, because they're opposite numbers, and they cancel to make what? 0. And so you're going to write -7 plus 7 equal to 0. Are we there? Okay, so we got that one down. Now, to the right side of your page, you have still space to the right. Is that correct? You don't have to write the words anymore, but write example 2. And you're going to write the next two numbers that I want you to show me with tiles, and then copy the picture underneath the numbers. Yes? Here it goes. Example number 2. They want you to represent -3 plus 3. Get those tiles in front of you, and then draw your picture. Circle your 0 pair. It looks like we got, let's see, does your picture look like this? 1, 2, 3, 1, 2, 3.
Yeah.
And why do we cancel these? Because they are what?
Because they're same number.
0 pairs, or also known as opposites, right? Okay, so far so good? Last one of these, example number 3. Do that one. See if you can go a little bit faster now. Alright. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You circle this, cross them out because they're opposites, or also known as 0 pairs, and this became 0. Hands if you got that. Alright. So, copy this next one including the instructions. Example number 4. Copy that. Example 4, including the instructions. It says, represent -1 using algebra tiles and 0 pairs. Represent -1 using algebra tiles and 0 pairs. Copy that. Okay, check this out. Pens and pencils down really quick. Look up to the screen. Let me just help you transition to this one. Look at the previous one. Here we had 10 and 10 negatives, and they canceled, and we're left with nothing else, right? That's why it's 0. Look at the previous one. 3 and negative 3, they cancel out. There's nothing left. That's why we end up with 0. However, for this next one, they're asking us to represent -1. Not 0, -1. But they also want us to use 0 pairs. So what is the first thing that you think as soon as you see that they want us to represent -1? What do you do? Yes. So he said, put down a negative tile. Who agrees with that? Okay, do that please. Put that in front of you. But it also says to use 0 pairs. What would I do there? Yes.
Put down -1.
-1 and?
Oh, 1.
And 1. Is this a 0 pair? If I... No, here, this one that I circled. So this is a 0. What do I have left?
1. -1.
So does this represent -1?
Yes.
Yes, okay. Let me show you another one. Who's got the idea now? Okay, what would be another one? Let's see. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6. Okay. Is this -1 also?
Yes.
Yes. Copy those two down, please. Very good. Okay, let's move on. Copy this next one down. You don't need the instructions for number 5. Just copy the number that, just write represent. Here it goes. For number 5, write example 5 and write represent +4. So think about it. Think about the one we just did before. The other one we represented -1, right?
Yes.
This one they want us to represent +4, but they also want us to use 0 pairs. Put those tiles in front of you. See what you get. Tell me what to write. Go. 2 negatives. 6 positives. Circle on the positives. Oh, 2 positives and 2 negatives. Okay. Why do we do that? Why do they cancel out? So you get a +4, but why do these cancel out? What are those called? 0 pairs, or also known as opposites, right? Does everybody agree with this?
Yeah.
Did anybody get something different?
Me.
Yes.
Oh, I put 8 positives.
1, 2, 3, 4, 5, 6, 7, 8.
And then 4 negatives.
1, 2, 3, 4.
Got 'em. Bam. And then I circle that.
Circle your 0 pairs.
And then you cross that out. And
4.
put 4.
Thank you. Yes?
Would it be okay if you just put one opposite, and so it's like 4 left still?
What?
Tell me what to write.
5 positives and 1 negative.
1, 2, 3, 4, 5, and 1 negative. Is this representing 4?
Yes.
Yes. So, that is true. So think about this question. Since all of these are representing 4, what is it that it doesn't really matter for us to add to the amount? Think about it. If this is 4, if this is 4, and this is 4, what doesn't really matter? Think about it. Yes. How many, you're very close. How many, Jenrick? How many 0 pairs? Does everybody see that? Does it really matter how many 0 pairs I add to the side of it? No. Let's make a note right here. Put a little note right here. Put an asterisk. Make a heart. To remember. You're going to write, when representing representing integers with tiles and zero pairs. It doesn't matter how many zero pairs to use. Oh, sorry. Whoa. To use, comma, because blank. Fill in the blank. Why doesn't it matter? Because it's always equal to
plus 4
or 0. The zero pairs is always equal to 0. Good. So, here goes the challenge 1. Copy this one. Example number 7. It says, show me -6 plus 9 using algebra tiles and 0 pairs. What amount does that represent and why? Show me -6 plus 9 using algebra tiles and 0 pairs. What amount does that represent and why? So get those tiles in front of you. What do you get at the end? Write it down. Copy your picture.
representing positive 3.
-6 plus 9
Is representing positive 3.
represents positive 3. Oh, plus 9.
The bottom.
Okay, show me your picture. Tell me what to do.
You write 6 negatives
6 negatives,
and 9 positives.
9 positives,
And then you have to circle your 0 pairs.
circle your 0 pair,
Cross them out, and then
you're left with 3 positives.
the bonds.
Hands if you got that by yourself?
This
Good.
is
Now, what we did today, we added positive and negative numbers. And I didn't have to give you the rules of if the biggest number is negative, or the da-da-da-da-da-da-da. We just focused on how many properties? 2. What were those properties? Let's see. The additive inverse property and the identity property of addition. Think about the definition for those because you're going to need that for the homework for tonight. Okay? So get a blank sheet of paper, copy the homework. Homework is only 4 questions. Number 1, in your own words, define 0 pairs or the additive inverse property. Number 2, in your own words, define the identity property of addition. Number 3, represent a 0 pair using tiles and describe it in your own words. And number 4, represent -7 plus 12 using tiles and 0 pairs. Describe your number in your own words. When you copy this, make sure you copy the question. Leave about 3 to 4 lines of space so you can answer it at home. Remember, at home, you need to do this in pencil. Okay, copy those questions down, please. And as soon as you're done, you may leave. Have a good one, everyone. Enjoy your homework. I'll see you guys tomatoes.